So hello everyone, this is Group 3's embedded project. Our project is beneficial for companies or people who provide transportation. The project provides security for anyone who acquires a transportation and service. So why security? Because the system wants our drivers to be safe, to deliver our passengers safely to their destinations. In the screen is our device name with logo, steering wheel, heartbeat, and the device name Safe Steer. Our embedded system is inside the steering wheel that could help to monitor the heart rate and temperature of our driver. So here's the description. Safe Steer is a system designed for drivers to monitor and alert themselves of their heart rate and temperature. Since drivers don't have their time because they're mostly on the road to monitor their safety, this will be a great system for them to monitor always if an abnormality occurs. So here, if something happens, if the driver has a high blood pressure or when he suddenly drops temperature or suddenly gets a fever, a warning sound will alert the driver, saying that the driver is unsafe to continue the trip.
Hello everyone, good day. I'm Ryan Napiawan and I will be the one to explain the components of our project. Discussion of components. The first component we will use is the Arduino Uno R3 or our microcontroller. Arduino Uno has a flash memory of 32 kilobytes, a clock speed of 16 megahertz, and a power supply from 6 to 20 volts AC or DC. The Arduino Uno is responsible for calculations and where the components will be interfaced. Next component is the SLIM900A or the GSM module. This GSM module used as a communication and has a mobile SIM attached on it. And this module will be responsible for the transmitting an alert system, an alert alarm to the respondent or to the authorities through message or SMS. Next one is the heart rate sensor. Heart rate sensor is the one to measure the heart rate of the driver, and it requires a constant pressure and also not too hard and not too soft to give a signal. Next component is the LM35 or the temperature sensor. This LM35 is measure a precise centigrade temperature and continuously measure body temperature when it touch. And our last component will be the LCD or the 16 by 2 character LCD. This LCD displays the health status of the drivers like its heart rate and its temperature. The LCD has 32 box characters into the outline. And with an LED backlight enables optimal viewing in all lighting conditions. And that's all about our components. Next one will be the development and it will be discussed by my group. Thank you.
So here's our conceptual diagram or user guidelines. Our technology will work when the car starts or engine starts and the steering wheel will be activated. After that, it will start sensing. This negative and positive sign represents the abnormality of the heart rate and temperature of the user. So if our sensor detects abnormality to the heart rate and temperature of the user, it will send an alert. And our alert has two levels, which is alert level 1 and alert level 2. Alert level 1 notifies the driver or the user by activating the alarm and speaker, while alert level 2 will send an SMS alert to the authorities. So here's our physical layout. So in our input device, we can see a heartbeat sensor, LM35 or our temperature sensor, a button used to turn off the speaker, our microcontroller, the Arduino Uno, GSM module for our network support to our technology. For the output devices, the LM016L or our LCD, the emergency light, alert sound, and an SMS alert. So, in our program code, the libraries use is the liquid crystals, which allows the control of the LCD. The token vocab US large generates speech from a fixed vocabulary used in the alert sound of the system. The software serial, which allows serial communication and other digital pin. So here, this two is our digital pin designation and variable declaration. Next is the void setup. This setup function is called once when the program starts. We can see here the installation of pin, mode, and serials. Next. Yes. To be organized, 5 functions were defined in this project, namely display health, display level 1, display level 2, display halt, and send message. These functions are programmed to perform the output tasks of the system, such as the output display in the LCD and SMS messages. And lastly, this loop function consecutively loop on the code inside it. The reading of heart and time signals or input is programmed in this segment. Conditional statement were also included in order to decide which defined function is to be called. And that's all. Thank you.
So here is our simulation. In this part, we have the input devices. In this part, we have our output devices. But for the sake of simulation, we have used the lamp and the sounder here in Proteus to simulate the emergency light and the speaker of the car. We also included here a potentiometer, which we could twitch and change to simulate the changes in signals, especially here in our heart rate sensors. So we are going to show the two major features of our system, which is the alert system level number 1 and alert system level number 2. So we have designed the system to alert when the heart rate goes beyond 100 and when it goes below 70, because below 70, that's when the heart rate of a drowsy person lies. And for temperature, of course, it should not go beyond 37 and it should not go below 36. So let's see what's going to happen. I already played it. It says here, go forward, safe steer. As you can see, we have already 64 as heart rate, and that's abnormal. The alert level number 1 should be triggered or activated. And if I press this button, the monitoring should be halted. So it says here monitoring halted, which means that the driver is all right, he's awake, and it should go, but for a period of time only. So after a period of time, it should go back to monitoring. And we have tweaked, for the sake of simulation, we have tweaked the time to fit in the video. And now I am going to show alert level number 2, which means that I would not be pressing this response button. And the sounder is buffering now. So it says here, no response, sending SMS. So that's alert level number 2. So the message will be sent to this number, and it says, please track me, there is a health emergency. Also, the emergency lights will be turned on. If you can see, there's a yellow light coming out of this lamp or light bulb. But so those are the major features of our system. This could be enhanced by adding maybe a GPS function feature. But since cars this day and phone numbers are easily tracked, we did not include it for now. And so that we could focus on these major features of the system. And we believe that these features are enough to maybe wake up a drowsy person and give information about the well-being of the drivers. That's all. Thank you.